Hi class, today I am going to make this video to finish off the notes for 222 about the areas of triangles and composite shapes. So my first video from yesterday covered number 70, parts A, B, C, and D. So if you haven't watched those, I would go back into Google Classroom and take a look at those. So we're going to start here with 270E, and we're going to talk about finding strategies to measure area. So we want to find the area of the shaded region here. And so the area, we know the area of a rectangle is length times width. So what we can do is we can find the area of all of this, and then we can divide it in half because we know that it's a triangle. So the area of a triangle is half your length times your width, or some people say base and height, which is fine too. So we know that the area is going to be half the length, which we can say is 14, and the width we can go ahead and say is 5. So we can say half of 14 is 7, and then 7 times 5 is 35 yards squared. So now let's take a look at the next triangle. I'm going to start using base times height because I feel like that might be a little bit more helpful using the keyword height instead of length or width. So in the next one, it is a triangle. So once again, we want to use half your base times your height, or length times width. And in this one, notice that this is not a right triangle here. We don't have a right angle right here. But what we can do is we can still figure out the height of this problem by using this 5 here. So the height is always represented by a line that's perpendicular to the base. So this pink line is perpendicular to the base of the triangle, so that's going to be your height in this in the situation. So we're going to say half your base is the entire length of your bottom here. So 4 plus 10 would give us a base of 14, excuse me. So 14 times your height of 5. And so once again, we're going to get 7. Half of 14 is 7 times 5, which would give us an area of 35 feet squared. Now the units are different in both of these triangles, but take a look and notice that although the triangles look different, because they have the same height and the same base, they're going to yield the same calculation of 35. It's just that the first one's in yards and then the second one is in feet. All right, so let's take a look at number 37. 71. Ismail claimed that he did not need to calculate the area for part F in problem 270. All right, so Ismail claimed that he did not need to calculate the area for part F in problem 270 because it must be the same area as the area for the triangle in part E. Explore using the area of a triangle. So what Ismail is talking about is what I just kind of talked about here with you, is the fact that the height and the base are the same. So that means that they're going to yield the same value when you calculate those same numbers. And if we click on this explore the area of a triangle, we can kind of, so notice here on the left, we're keeping track of our height and our base. So our base is 6 and our height is 5. And then if we wanted, we could rotate this triangle to make a square, or excuse me, a parallelogram. Check that out. If we rotate that, we get a parallelogram. And then we can kind of skew it. We can change that height there. And then notice that the area is down here. So they're keeping track of base times height divided by 2 for that triangle, for that blue one. So I'm going to rotate that back so it's just a triangle. And so notice when we skew it and we change the way that our triangle looks, it has the same height. Now notice that I told you that the height needs to be perpendicular to the base. And so it is, even though it's on the outside of the triangle, the height is how tall your triangle is. And it will always make a right angle with the base if you extend that base with dotted lines. And then if we skew it, notice that if we turn it this way and then the height is on the inside of the triangle, it still has an area of 15. And then if we skew it a little bit more the other way, look, still an area of 15, even though the height and the base has changed. All right, let's go back to notability. So is Ismail's claim correct? Yes, it is. How do you know? Draw diagrams that show your thinking. So how do we know? Well, we know that the height is still the same. And the base is the same. And then the area formula is always half your base times your height. So if you're multiplying the same base and height, it'll be the same. Do all triangles with the same bases and heights have the same areas? Use your technology tool to investigate. Yes, they do. We already tried that to investigate, and then we were missing some diagrams from the beginning. So what we can do is we can draw a diagram and say, okay, if I have a height here of 4 and a base of 10, that would be the same thing if maybe we had an obtuse triangle with the height of 4, and then the base is going to be the same thing, which would be 10. So those are two different triangles that would have the same area based on their height and then how long their base is. All right, in part C, explain why the area of the triangle is half the area of a rectangle that has the same base and height. That is, show the area of a triangle must be half base times height. So we can just show that because any triangle, as we can see in the Desmos, can be rotated. And maybe I need to show you that again. If we rotate that triangle, where's the rotation tool? If we rotate that triangle, we'll see that it creates a parallelogram. And maybe it would help if we made our base 4 and then our height 4. So now we have this triangle here. And if we change the skew, notice that the blue triangle is half of that square that we have here. So let's go ahead and draw that in and show that if you have a triangle, if you have a triangle, it's always going to be half of a parallelogram or a rectangle. So here's an example here. And so this is half. So the area is going to be your base times your height divided by 2. Because it's a triangle, it's half of that. All right, part 72. How do you know which dimensions to use when finding the area of the triangle? Because you're always going to use the length of a side, which we'll say is our base. And then we want to use the height. Sorry, I didn't give a lot of room to write in here. The height, which will be the line perpendicular to the base. So a line that's perpendicular to the base. So in example 1, 3 is going to be your height because it's perpendicular to that base. So 3 is your height, and then your base is going to be that 14. So the area is half your base, which is 14, and your height, that is 3. And so then when we calculate that, half of 14 is 7. times 3, which would give us 21 millimeters squared. And then for part 2, our height this time is going to be 6.8. So your height's going to start at a vertex, and it's going to make a perpendicular line with another side. That's going to be considered your height. So we're going to say your height is 6.2. So half your base is 5.9, and then our height is 6.8. Your height is always the side that's perpendicular. So height. And then we can go ahead and calculate that to find our area. I'm going to pick up my calculator and use that. Half times 5.9 times 6.8 should give us a 20.06. And that's inches squared. And then if we look at number 3, once again, our base, you know what, it might be easier to find your height. Your height is always going to start at a vertex, and then it's going to be perpendicular with the opposite side. So the 5 millimeters would be your height. And then your base is going to be 6 plus 2, which would be 8. So your base would be 8. So area equals half your base times your height. So half of 8 is 4 times 5, which would give us an area of 20 meters squared. Okay, this is the last question for the notes. Mario, Raquel, and Jocelyn are arguing about where the height is for the triangle below. The 3 have written their names along the part that they think should be the height. Determine which person is correct. Explain why the one you chose is correct and why the other 2 are incorrect. So I'm going to go ahead and give you about 30 seconds to figure out. We're going to do like a Dora the Explorer kind of activity where I give you some time to respond, and you're going to write it down or you're going to think about it. And if you want, you can shout it out just like Dora, and then I'll tell you in a moment. All right, so the correct answer is Jocelyn. Jocelyn is correct. And Jocelyn is correct because hers starts at a vertex and it comes down to the opposite side to make a right angle. Raquel's line does not make a right angle with any side. And Mario's does make a right angle with the side, but his does not start at a vertex. So that's why Mario's is wrong. So Jocelyn determined the correct height for hers. And now we've got a learning log. So in the learning log entry, you're going to describe at least 2 different strategies that were used today to find the area of an irregular shape. For each method, be sure to include an example. So what I would like you to do is maybe pick one of the figures that we did to find the area in these slides today. And if you could just maybe write maybe step by step, like for the first thing we did was that, and the second thing we did was that. So just kind of write out what we did step by step in order to find the answer. And then when you're done, this is the same thing we just did. When you're done, you can go ahead and submit your Google Slides to the assignment so that I can read your learning log, and then you can start on the assignment. I'm going to start assigning closure problems to wrap up the chapter so you don't have to do all of them at once. So there's going to be like a closure part 1 assignment for you to do either today or tomorrow. All right, have a good one, guys.